and he's going to take us through a very important topic, and that is how to get your Unreal Engine game onto mobile. Thanks, Arvind.
Thank you so much, man. Vanakkam, Chennai. Nalla irukingla? Good? Awesome. Last talk of the day. I know you've all had your snacks and lunch, and you're probably like looking forward to some tea, coffee. Just wait 45 minutes. I think you'll have a good conversation over your coffee at least, talking about how you can use Unreal Engine for mobile. So this is, I don't know where my slides, are my slides being projected somewhere? Yes, great, okay. So this is the agenda of this talk, right? The talk really is about an introduction. I'll talk to you about what I am, who I am. But the meat of the talk really is about the technical expectations that one would have as a developer or an artist when they are developing a mobile game or a cross-platform game which has a mobile element to it. And finally, I'll also talk about all the ecosystem and the next steps. Now, before I go there, how many of you here are Unity developers? And you can be candid, right? Great. Like there's a lot of Unity developers. I think all the Unity developers have gone to the left side, my left side. But there's a lot of Unity developers, and it's true. Like there are a lot of Unity developers, and I used to be a Unity developer myself. And really, the crux of this talk is things I wish people had told me when I was switching to using Unreal Engine from Unity. That really is what this talk is all about. Now, this is not an editor parity talk. I'm not going to say, hey, here is the scene view, and here is the level view, or here is the inspector, and here is the details. I am not going to do that. There's a lot of people who have done it. This is purely stuff that I wish people had told me, which would have made my life so much easier when I was beginning to use Unreal Engine. So quickly about me, I am a solutions architect at Epic Games. I have been with Epic for the last 5 years now. I just realized I just completed 5 years just last month. LinkedIn reminded me of it. And my focus has been working on mobile and optimization in general. And I also previously worked at Unity for about 4 years as the head of technology. So I know a bit about like the struggles of moving from one engine to the other. Now, mobile is very, very important for Unreal Engine. So we have been putting a lot of work. So when we talked about editor parity, there is a really good Epic developer community portal where there is Unreal Engine for Unity developers article, where it does talk about editor parity and generally how the architecture of Unreal Engine differs from what Unity does. So if you're interested, just kind of check it out. There is also some very inspiring stories about how and why some of the studios are switching to using Unreal Engine itself. So if you're interested in hearing those stories, the technical reasons behind it, or even the artistic reasons behind it, check that out too. So let's get into the meat of it, right? What is the technical expectations that one have when they're making a mobile plus cross-platform game? The most important thing is when you're making a PC, console, or a mobile game, you shouldn't be having to branch your code base to maintain 3 different code bases for PC, console, and mobile. I think we all agree on that, right? You want to have one code base for all of it. So that's a given. Subsequently, I kind of also set out 4 quadrants for how you can judge your workflow, how you can judge your engine. First one is developer efficiency. So it's all about making sure that whichever engine that you're going to be choosing has great editor workflows. There is a development and deployment ease. CI/CD pipelines, which is your continuous integration and deployment pipelines, are all set. You need to be able to test your games very easily. And finally, you're always working as a team for the most part, unless you're solo devs. But even regardless, there is a team effort involved. So you want to have the engine provide as much help for you to work as a team. Agreed, right? You want that developer efficiency. The second quadrant is all about mobile memory and optimization. You want to make sure that the game that you're deploying is optimized. The assets are almost auto-optimized. You need to have the right kind of tools which enable you to identify these memory leaks or memory issues that you might be having with your game, And finally, you also need to make sure that there is a good build and asset delivery system so that your assets are, so that your base build is a certain megabytes, and then you're able to then deliver and patch your assets through like DLCs in an efficient manner. The third quadrant is visual fidelity, and this you just want the engine to take care of it, right? You just out of the box, you want your engine to just, or your game to just look amazing, right? And so, which means that you want the engine to be rendering up-to-date rendering techniques on the mobile phone. It just should look spectacular. And final quadrant is third-party support. So like when you're making a mobile game, you want to have in-app purchases, ads, any kind of third-party library support, like Netflix games is becoming big, or Apple Play SDKs that they provide should also be easily integratable into your game, right? So I would say roughly these are the 4 quadrants that you would look at when you're making a mobile game. So now, using Unity as one of the reference points, let me walk you through how Unreal Engine performs on all of these 4 quadrants, and that really is what this talk is all about. By the way, nothing against Unity. Unity does what it does really well, but I'm just using Unity as a reference point only, all right? And I'll be talking about factual differences. This is not opinionated differences. I'll be showing you what those factual differences are so you understand that. So let's start from the very, very, very beginning. Let's start with the first quadrant, which is the developer efficiency, and look at how Unreal works. First off, this is not Unreal, that's Unity. You must be very familiar with it. In Unity, if you go and create a brand new level, completely empty level, and hit on play, this is what you would see. You would see that the hierarchy is mostly empty, it's completely empty, and that's what you would expect from any game. When I started moving from Unity to Unreal Engine, this is what happened. This is Unreal Engine. I went and created a completely blank level. I clicked play, but suddenly the outliner is just populated with stuff I did not even add. Now, how many of you have been confused by this? A lot of people. I was confused as hell, because I was a Unity user. I want a blank scene, and suddenly in the blank scene, there are so many things that got added in it, which I did not add at all. So what's up with that? In fact, this is one of the biggest differences between Unreal Engine and Unity, because Unreal Engine takes care of a lot of the boilerplate which you are going to be adding over and over again when you're making any sort of game. So let's look at any game, right? All games have this. They have game rules. There is a player or players. There are cameras. There is player information like your name, score, and whatnot. There is a user interface, which is a UI. You have inputs from the player, could be touch inputs, keyboard, mouse inputs. And of course, there's the starting position for the player. This is true with almost every game, be it like a first-person shooter game or even like a match 3 game, have the same things. Will you all agree? Yeah? That's exactly what gets added into the outliner. When you see all the things that just automatically got added even in an empty scene, that's pretty much it. When you look at the game rules, it's actually called game mode base within Unreal Engine. Players are called default pawn. Player camera is the player camera manager. Player information is the player state, and so on and so forth. And that's what gets added automatically into Unreal Engine. And if you want to modify this, you can of course go under project settings. There is you can change what your game rules are going to look like and change your game accordingly, but all of the information I told you earlier about what every game looks like stays the same. And all of this just works automatically. I hate that word. I don't like when things work automatically. I want to know how things actually are going to be working behind the scenes. So let's look at that. The nice thing about Unreal Engine is the source code is available on GitHub. It's not a black box. So if you want to dig deep, kind of see what's up, you can go to the source code, get it from GitHub, and if you look at this particular class called world.cpp, that's where there is a function called initGame. And in that initGame function, there is a game mode base that gets instantiated, and you can see all those functions all the classes actors that I mentioned earlier are essentially instantiated in world.cpp, subsequently in game mode base.cpp class. If you comment all of those lines out, you essentially get Unity. You're like, yeah, Unity, I can now be familiar with what's up with that. But I wouldn't recommend doing that because what this is, what you're looking at in the outliner is really the very, very robust gameplay framework. And that's pretty much the base on which all of Unreal is being built on top of. In fact, every game that you see that's being made with Unreal Engine, within Unreal Engine and outside of Unreal Engine, is built on top of this gameplay framework. In fact, there's a very, very nice article on the Epic developer community. If you're not there, almost all of our documents are over there, including documents that are written by our community. So do check it out. It'll give you like a good overview of what that gameplay framework is all about. Every game, be it like a third-person game like Lyra, which is a free project that you can get from a Fab marketplace, is using the gameplay framework. Or if you're making a third-person top-down RTS kind of a game, that also uses the same gameplay framework where you're changing the rules for that game. Or if you're making a brawler or a FPS or a dungeon crawler, every sort of those games are all made with the same gameplay framework over and over again. And by the way, whatever that you're seeing here are the new templates that's available with Unreal Engine 5.6. So it'll help you like get started almost automatically. And it's not just games that we made, it's any other game that's made by other people, like even be it the Tower of Fantasy Hota, which we'll be looking at in just a bit of time, or the Oregon Trail, the Nina Kuni, or even Fortnite uses the same gameplay framework to make all of the games. And not just games outside of India, even Indian games are making this only. So if you look at new games that's coming out like Son of Tanjai, Raji, Age of Bharat is a new game, or Light Fury, or Dream Cricket, all of them are using the same gameplay framework. So the point is, don't fight it. It's there to help you out. It just helps you kind of accelerate your game development very, very rapidly. So let's look at the gameplay framework itself. Now, when I click play and when I select any of the objects that you're seeing in the outliner, all of these objects are movable, right? You can select it, you can move it. And this brings me to the second important conceptual difference between Unity and Unreal Engine. So let's talk about the objects that you're seeing in the scene in Unity. Now, any object that you can see and edit in the scene window is called in Unity, game object, right? Game object, right? That's a game object. So here I'm adding a cube, and when I add the cube into the level, I can move it, I can do all the things that you would expect to do in the scene. Now, all the properties of the cube, such as its mesh and its material, is all stored as a component, and in the component, you can modify these components, or you can add new ones to modify the cube to make its behavior different. Now, Unreal has a similar paradigm. Now, all the objects that you see and modify in the level is called an actor. And these are actors, and all of these actors have what is called actor components, which are then what defines the properties of the actor. So like in this case, the cube, which is an actor, has a static mesh component, which is what makes the actor act as a cube, which is the mesh on top of it, correct? And similar to Unity, you can also add actor components to the actor by clicking on the add button in the details panel and make it and modify it the way you want it. Now in Unreal Engine, everything is either an actor or an actor component. If you go to like main.cpp class and just start drawing the line, you will see everything that you see inside Unreal Engine, regardless of what kind of asset it is probably an actor or an actor component, which by the way is inherited from the uObject class. Now, you will see some old friends in this image, which is a gameplay framework, and kind of like a Scooby-Doo episode, if you remove the mask out of the gameplay framework, those are also actors. Again, if you see all the highlighted orange ones, those are actors again. So nothing magical about Unreal Engine and actors. Is just like helping you with a lot of the boilerplate that I was talking about earlier. So let's look at some very specific Unreal Engine workflows, because remember, we are actually talking about the developer efficiency part of our talk. So let's go to that real quick. Let's talk about some of the tools available within Unreal Engine that helps you just be very efficient with your development itself. So first off, you have this really cool feature where you can enable preview platform within the engine itself. So if you're making a mobile game And you don't want to keep deploying to the device again and again. You just want to see what is my game going to be looking like on an Android platform or an iOS platform. Unreal has a very, very solid previewer within the engine itself. So that means if you're previewing for Android, you can say, like, you can see the difference, right? If I click on default, that's what my editor will show. But then if I say I want to preview something on a Vulkan high device, that's what your render will look like. And Vulkan low, that's what it'll look like. And same paradigm applies for iOS also. So if you're going for metal high, metal low, and so on, you'll have a very clear idea as an artist or as a developer what your game will look like on the target platform. We also have excellent Android emulator support. This is the official emulator provided by Android, by Google, where if you go and launch a emulator, that emulator is now connected into the Unreal editor itself, so you can launch a game from your editor to the emulator, and this is a great way for testing out your game, because you wouldn't have hundreds of Android devices lying around if you want to be testing. And this is how, in fact, Fortnite itself also does the testing, I believe, which is you go in there, you create multiple emulators with multiple configurations, multiple screen sizes, and all of them would be launched from the editor, so you can test out your game on multiple devices, resolutions, memory, and so on quite easily. If you're a C++ developer, you don't want to keep, when you're deploying your asset for testing purposes, you don't want to be cooking or deploying your assets, which are quite heavy, into your mobile device every time. So there is a very nice C++ only deployment option, which is called don't bundle libraries into APK. There's a checkbox up there on project window, or you can also just change the default engine.ini file to do that. Now, I can hear artists already whispering, saying, okay, great for C++ developers, but artists, do I still have to keep deploying? Not really. We have introduced something called Zen streaming, which is just amazing. Typical way of working is you build your game, you cook your content, you stage your content, and then you deploy it into your target device. Depending on the size of your game or the time or the number of times that you're building, it can take quite a bit, right? I think Unreal developers on this side, you agree, right? Takes a while. With Zen streaming, that goes away. We have, what Zen streaming does, and I'll show you a demo in just a bit, you have already cooked those assets inside your computer, inside your development machine. So rather than deploying those cooked assets into your mobile device, you can stream those assets as you're playing the game. So on Fortnite, which is a humongous game, deployment took 27 seconds to the device. And I can see people going like, what? How does that work? Here is how it works. If you turn on Zen streaming, and turning on Zen streaming is just one checkbox, you'll notice that there is a little text over there which says it's streaming from my device. So when I click on play, the right hand side is my mobile device, left hand side is my editor. All the assets that I've already cooked is just streamed into the mobile device, which means for testing purposes, I don't have to wait. I can just see what my game looks like almost instantly. So if you're not using Zen streaming, you should today. It's awesome. But of course, when you're deploying the game for production, don't use Zen streaming, because everyone has to then carry your laptop with them. And you can learn more about Zen streaming from this QR code, but turning on Zen streaming is super easy. Just go to project settings, just say, yes, you want to use Zen server, check that, and select the IP, and you're good to go. And add a couple of lines in the default engine.ini file. But you can learn more about it from the QR code. So with that developer efficiency, and suddenly you're like, well, yes, of course, we're talking about the 4 quadrants. So we finished one quadrant. Let's get into the second quadrant, which is mobile memory and optimization. So let's go back to Unity, and let's go back to the building blocks of Unity itself, which is prefabs, right? Now, creating a prefab in Unity is actually quite straightforward. You create a game object, you drag and drop it into the project window, and that's about it. It's as simple as that to create a prefab. And you can, of course, edit the prefab in the prefab window. You can add and edit components. Now, some of the things about prefabs in Unity is Prefabs are kind of flat, and they don't really support your traditional object-oriented inheritance in the same way that scripting classes or programming classes do. And there is, of course, an alternative data-driven approach to all of this through the concept of prefab variants, where you can create a child prefab which then inherits the properties and structure of the base prefab, but these are more like templates for game objects, are not really truly inheritance in a programming sense. Now, heading back to Unreal Engine, for the most part, the equivalent of prefabs is blueprints. And that said, blueprints are more structured and are fundamentally class-based. And they support inheritance in an object-oriented programming sense. So if you're a C++ or any kind of programmer, you'll kind of get it automatically. So remember that actor and actor component I showed you earlier? You can see that in the hierarchy also, everywhere inside Unreal Engine. If I create a new blueprint, you can automatically see, hey, actor is on the top, pawn inherits from actor, character inherits from pawn, player controller inherits from actor, but everything essentially is an actor at the end of the day. You can add actor components in the blueprints just as you would expect, as you would do in a prefab also. So here I'm adding a static mesh component, and I'm adding a cube mesh in a static mesh property, and you can make it do pretty much what a prefab does for the most part. But the real superpower of blueprints is that it comes along with visual scripting. So when you're adding custom components in Unity, you are writing a C# class which extends mono behaviors. And if you look at blueprints as the visual scripting language, it's incredibly powerful that you're able to pretty much ship entire games without writing a single line of code. Because, in fact, Cropout, which I showed you earlier, the game, is entirely made with blueprints, and it's production ready. So this means that as an artist or a technical artist, you're now able to contribute more into the game development cycle itself rather than having to wait for a programmer to write code or a script. So here are my absolute top 5 blueprint features which just make it amazing, right? This is my opinion. First off, source code availability. If you're looking at blueprint and if you're a programmer who hates black boxes, you can always double click a blueprint node and it'll just open up the source code and it'll show you exactly what's up. Second, exactly like any programming language, you can add breakpoints. You have a call stack. So here I'm adding a breakpoint. And when I'm running a game, it'll breakpoint to that particular node so you know what's up. And you also have a call stack, which means you know exactly where that particular node is being called from. So there's a call stack, and you know where that is called from. You also have logical flows. So when you click on play, that node wiring will get fired when your game is running. So you know exactly where and how your logic is flowing, which I love. So that's still number 4. Number 3 is one of the big complaints about blueprints is like, hey, I can't use it if I'm using a version control tool. Well, not entirely true. Yes, you'll still have to find workarounds it, but Unreal has Unreal Diff tool. So if there's different versions or even local versions of the blueprint, you can compare it side by side to see what has changed within that blueprint, which is amazing. Number 2, which when I heard it just blew my mind, is blueprints can be copied to a text file. So in this case, let's say I copy these blueprints and you're asking for help for someone, rather than sending them a screenshot, you can essentially copy the entire blueprint, Control-C it, you can paste it on a notepad or any other text file and it'll show you this very unreadable thing, but this is readable by many people, like including Unreal Engine. So if you go to say blueprintue.com, for example, you can paste that blueprint that I just copied and create that blueprint. It'll actually show you the same blueprint that I just copied from my editor. And this can then be sent to your friends as an email so that if they are debugging something, you don't have to send screenshots or they don't have to recreate your blueprints manually. Literally copy paste blueprints and it'll just work in the editor just like that. This also works for shaders also, which is just spectacular. When I knew about it, I was like, awesome. Finally, my number 1 favorite things about blueprints is blueprints are treated like content. What does it mean? So in the context of Unity, let's take the case of asset bundles, which are just compressed archive files that contains your game assets, correct? So they're used to package and distribute assets in a way that allows you to have on-demand loading or DLCs. But the problem with asset bundles is they cannot contain assemblies, and you can't really use them to distribute like new C# classes or changes to existing classes itself, correct? But in Unreal, and when you're using blueprints, because blueprints compile down to bytecode, they can be packaged into pack files, which is the equivalent of asset bundles. So blueprints are treated like content, which means blueprints, you can add new logic into your game if needed, and they can be added into your downloadable content or DLCs. And the nice thing about blueprints is they're only loaded on demand, which means unless they are referenced by some object, it'll never get loaded. It'll not be there in memory at all. So it's always a good idea to keep your blueprints very modular. And of course, blueprints referencing to other blueprints will get loaded. So you need to make sure that that reference is up. But if you're like, hey, how do I know what is referencing to what? There is a really nice reference viewer within Unreal Engine. So you can right click on any blueprint and see, is there something that's referencing my blueprint? Check it out. And then you can say, oh man, that shouldn't be there. Remove that reference. Immediately your loading of your game will also like kind of dramatically decrease. Now programmers, I can hear them scream saying, oh, performance, man, come on, like C++, best performance ever. Blueprints, not so much. Not true. When you look at this chart, which is very cryptic chart, but let me break it down for you. The TLDR of this chart really is, if you are going to be benchmarking blueprints from a developer build or from the editor, it will suck. It'll be terrible. So don't benchmark it. And that's what you're seeing over here. The PIE, which is play in editor, it shows like terrible performance of blueprints right here. But the next one is, if you are shipping a developer build and then you're benchmarking the same kind of blueprints, it'll still be bad. But when you're doing a benchmarking on a shipping build of the same blueprint, the performance gets significantly better. Of course, I'm not denying that C++ is not performance, which is the native one. So C++ code will still be more performant than blueprints, but this is running millions of calculations just so that I can make this chart. This is not the case when you're making a typical real world scenario. This doesn't happen. You will mostly be around here, right? So the difference that you'll see between writing C++ code and blueprints is not that much when it comes to performance, but when you're benchmarking, make sure that you're benchmarking on a shipping build so that you get the accurate result over there. If you want to know more about DLCs and asset bundles stuff, there is a really nice documentation on chunking. Check it out. I also wrote a nice EDC, Epic Developer Community article on that same topic. Now let's look at the difference between C++ and C# really quick. I know there is no one can speak about C++ in 45 minutes, but let's look at it from a programmer point of view. Like, why would you choose C++, or what is the difference between C++ and C#, or specifically Unreal Engine C++? The nice thing about, or the not nice thing about C++ in general is it doesn't have garbage collector. You have to manage memory yourself. But the Unreal C++ has a built-in garbage collector. You don't need to worry about memory management. So any object that inherits from UObject, and you know that pretty much everything in Unreal Engine inherits from UObject, will be marked as something that needs to be garbage collected. So you have a mark and sweep algorithm that will then automatically remove any objects that are not referenced anymore. And so it pretty much works the same as what you would expect in C#. And one thing to note about C++ is, unlike blueprints, which are loaded on demand, any C++ code that you write will be loaded upfront inside the game. So more C++ classes you have, then your loading time will also like increase. So just to keep something in mind. And when you talk about like garbage collection, and I hate this word, it just works automatically. So let's see it in action, right? In Unreal, we have something called Unreal Memory Insights, which is a phenomenal tool, which shows you like a graph interface on pretty much every UObject on the scene. And it'll tell you when something is being garbage collected or not. And this particular place that you're seeing here is where a UObject class that I referenced got garbage collected. And this is just proof to show you that, hey, it's not magic. It just works. You can see it working, and you can see it all working using the Unreal Memory Insights, which is available both for Android and iOS. Want to know more about it? I wrote a phenomenally amazing article on the Epic Developer Community Log on going deep into how you can use memory insights to identify every single part of your game and how to set it up. Another article that I wrote, this is about how you can reduce memory reduce the size of your game itself, which in fact shameless promotion. This was a talk I gave at UE Fest, Unreal Fest, Seattle, about 5 months ago, where I talk about exactly this, because reducing a build size is probably the #1 question that a lot of Unity to Unreal developers ask. I gave a full 45-minute talk on how to just reduce your build size, but I didn't want to talk about it again. But if you want to know more about it, do check out that talk. So let's get into the third quadrant, and I promise you this is going to be much smaller, about visual fidelity and rendering and performance, where you just want to have good-looking stuff on when you're making a mobile game. So let's look at Unity. In Unity, there are essentially 2 render pipelines that they have, right? So if you're going to be making a PC console game, you choose HDRP. And if you're going to be using a mobile game, creating a mobile game, you create the universal render pipeline, or URP. Which is fine, they both work great, but in Unreal Engine, we have just one pipeline, one rendering pipeline, and that's called the unified rendering pipeline, and that's the pipeline that you're going to be using, the rendering pipeline that you'll be using regardless of whether you're going to be making a mobile game, PC game, or a console game, or a cross-platform game that just works across everywhere. So that's our core philosophy, right? You don't want to be branching to maintain 2 different versions of the same game. You can have one render engine that does everything, and all of these steps that you're seeing here is the same regardless of where you're going to be publishing your game. And the visual fidelity actually is surprisingly awesome. This was not made by me, by the way. This is a YouTuber called Dear Impact, where he had a side-by-side comparison of this game called Tower of Fantasy Hotta. Left-hand side, or my right, is PC, and the other side is mobile. Same content, side by side on a Redmi 9 Pro Plus Max setting. It's quite similar, right? And in fact, this is Unreal Engine 4.27, which is almost 4 years old. So the point is, Unreal Engine has some fantastic rendering right out of the box for mobile. Another example is from Netmarble's King Arthur, Legends Rise. I'm going to play this video. Everything is captured from a mobile device. Nothing from PC. Amazing, right? That's entirely mobile. It's just spectacular work that they did. And these are some of the environments that they created using Unreal Engine for mobile, more environments. Another game that has been making the waves is Wuthering Waves. In fact, you can play this Wuthering Waves game at the Unreal Engine booth, which also looks spectacular on mobile itself. And this is just to show you that, hey, you can make really, really, really good looking games, and you don't have to compromise on visual fidelity and visual quality when you're making a game with Unreal Engine. Now, some of the newer features that has been added into Unreal Engine since UE5 is GPU scene, instant static mesh with GPU culling and LODs, landscape GPU culling, forward light optimization, and so on. Now, what does that mean? Let's talk about quickly about GPU scene. Now, GPU scene is essentially a way in which all the information about your objects are stored by the GPU buffer, and any other information, and all of this information, since it's stored in the GPU buffer, when it comes to rendering, it reduces the number of draw calls regardless of the number of objects that you have inside your scene. And it is also able to understand depth information. So you're able to do cool things like, one, you can have instant static meshes. You can also have instant static meshes which use GPU LODing, which is automatic loading based on the distance of your asset. And this is the same logic that's used for landscape. So if you have aspirations to make an open world game inside Unreal Engine, thanks to GPU scene, you can actually do that. You can have a very, very large landscape, like for example, an 8x8 or 64 kilometer square game if you want, on a mobile device, and have your character keep running and running and running, and GPU scene will take care of all of that. And that was added with Unreal Engine 5. Also, number one question I get asked is Nanite and Lumen on Unreal Engine, how does that work? Well, that's in works. Nanite and Lumen on mobile, rather. So we have been working on the desktop deferred renderer, which is currently being supported on high-end mobile devices with Vulkan, which will eventually allow you to have Lumen and Nanite to run on these platforms. So last quadrant, which is third-party support. What about ads? What about in-app purchases and third-party libraries, notifications? Now, there are nodes available, blueprint nodes available already within Unreal Engine. So if you're making ads, rather if you're showing ads inside your game, you have this node called show ad banner, hide banner. Now these are like elementary building blocks. These are not like complete systems. So you might have to write something on top of this, but at least it gives you a basic building block to show ads. Same thing applies to in-app purchases also. There is like a show in-app purchase or retrieve in-app purchases and so on, which again, building blocks for you to start writing on top of this to create your own in-app purchases itself. Sorry, I'm being shown time. I have like 5 more minutes. And of course, you have notifications, which is like, hey, there's a node where you just say, hey, I want to schedule a local notification. It just schedules it and it shows a local notification. So a lot of these building blocks for mobile-specific functionalities exist within Unreal Engine. And if you have a third-party SDK that has no Unreal Engine support, right? Like, someone has created, like say Netflix has created an SDK and there's no Unreal support, don't worry about it. There is an open source tool called apigear.io, which is maintained by Unreal Engine, which allows you to describe the protocol, describe your API, and it will auto-generate blueprints or C++ code for you. And then once it'll be enabled as a plugin automatically within Unreal Engine. Then you go in and write only the logic of what you want to do when you consume that API. So super easy to use. So you are kind of unshackled regardless of what plugin or what SDK exists. You can just kind of make your own make your own using API Gear. So to recap, what are the technical expectations? You're looking at developer efficiency, you're looking at mobile memory and optimization when you're making a game, you're looking at visual fidelity, rendering and performance, and of course third-party support. And I think Unreal Engine does quite well on all of these 4 quadrants. So if you're going to be or contemplating making a mobile game using Unreal Engine, I hope that this kind of let you at the very least think about it and saying like, hey, in fact, you know what, it's not so bad. It's not, yeah, I think I can make a mobile game using Unreal Engine itself. And I also hope that you understand what and how the architecture of Unreal Engine works. It's built on the top of this very robust gameplay framework. In addition to the ones that I talked about, there's also more gameplay frameworks like the Mass AI, which allows you to have like very, very large crowds, or other like gameplay ability system or GAS, which allows you to have like RPG kind of games constructed. All of that is just built as part of the gameplay framework itself. And it's not just Unreal Engine that we provide. There is an entire ecosystem of tools that we provide as Epic Games. So, of course, there's Unreal Engine, with which you can make your game. If you want to have content, which is third-party content that you can download from from fellow artists, or even first-party content made by Epic, like assets like Quixel, you can go to Fab. We also provide online services, like not like IT services, but like we provide a platform which enables you to have multiplayer game kind of automatically available for your game for free. In fact, Epic Online Services is free, and this is the same infrastructure that we use for Fortnite. And if once you make your game, you can distribute that game on the Epic Game Store, or if you're making a game in UEFN or Unreal Editor for Fortnite, you can publish that inside Fortnite. And finally, we also have a very, very large community. So we have Epic Developer Community Portal if you're a developer, and if you're an artist and you want to show off your work, do check out ArtStation to do that. And if you want to get started with mobile development with Unreal Engine, you can go to that QR code. If you scroll all the way down, you'll find an extraordinarily handsome face giving a talk on how to use Unreal Engine for mobile. And that's me. So it's a useful link on that front. And there's also a nice sample project that we just put out called the Parrot Sample Project. This is a game where if you go download it from Fab, there are two projects you'll get. One is a project made with Unity, another is a project made with Unreal Engine, and is exactly the same game. So if you want to like dissect, saying like how is Unity or how is Unreal Engine implementing functionalities that you're familiar in Unity, do check out this Parrot game. It's free. It's available on Fab. It's a nice learning tool. And we also have a Discord channel called Epic for Indies, which is where a lot of the indie developers get together, because I cannot answer all the questions, and so I would love the help from the community, and the community helping each other is what makes a lot of sense. So if you want to join the Epic for Indies community, if you ever stuck with a problem or a question, or just want to chat with fellow indies, great place to be. Do join it. And you can publish your game on a mobile store, on the Epic Game Store, which is now available on Android globally and on iPhone and iPad in certain countries. So that's also coming up. So that's pretty much it. That's my talk. I hope you found it useful, and I'm just really, really looking forward to seeing some phenomenal UE-made mobile games, and I hope you have a fantastic IGDC. Thank you. Yeah. Do we have time for questions? Yes? Yes? Awesome. Questions? And by the way, I'll be at the Unreal Engine booth if there's more questions. Yeah, please go ahead. Yeah.
As I told you yesterday, I'm a blueprint developer mostly. And I'm a little bit worried about the dispatchers, as you told about the garbage collection. And I think it's work same like for blueprints too, right? So how about the dispatchers? Once the actor get destroyed, what about what happened about the dispatchers? I watched a video on debunking video on YouTube.
Okay.
So it says you have to unbind
Yes.
the dispatchers. So is
Yes.
it really necessary?
Yes, it is. So rather than using dispatches, is always used. It's a good idea to just use like events instead, or event. So that way you're not binding the event or the dispatcher to a particular blueprint class. You're just saying you're kind of like pretty much shouting into a void, saying I am sending something. If someone is listening, listen to it. Otherwise, don't worry about it. And that's kind of the way you would want to work. Binding is typically a bad idea.
Okay.
Yeah. Good
Yes.
evening.
Hi.
Yeah, hi. This is Bhagat, placement officer and skill development trainer in an engineering college. Moreover, I worked in IT industry for nearly 10 years.
Sure.
So I really inspired and good work on doing this video, that is video games. So I would like to know what type of technologies and how you got an interest to create this type of video game that is you shown just now.
How I was inspired, or how is Epic making those games?
Yeah, yeah. What type of technologies is involved, and what kind of how to create if anybody is interested to start further?
I mean, I think that's what this talk was all about. Like, yeah, just
Yeah.
step one, download Unreal Engine. Good choice. Second, yeah, there's a lot of tutorials available. And we also have a lot of Unreal authorized instructors in India and Chennai who, if you are interested in a more handheld, direction-based, instructor-based training rather, you can also get in touch with them. But typically, a lot of these games, a lot of game development itself is learned from the internet, really. And that's how you make a game. I know it's a very, the question is also very broad, but I also kind of gave you a broad answer. But yeah, that's kind of how most people make games. And today, and if you're on the floor, you'll hear people making a game in a week, a small solo developer making a phenomenal, almost a AA quality game, and so on. So, and they all get started by downloading, first start downloading a game engine, preferably Unreal Engine. Yeah,
Thank you.
yeah.
Yeah, hello. From here.
Hey.
Yeah, I'm Munna. I have been working in Unreal Engine for almost 8 years, and I'm the lead developer at Matryoshka Games. One of the most things that that is criticized about the Unreal Engine is that it's not that quite optimized for mobile games, right? So basically, what do we think? That do I have to like download the source version and like make our own modifications to it, especially for the shader parts and like so many things that that runs behind the stage to make the quality look like more AAA, such as the PBS shaders and other stuff. So the build that comes, basically the binary build that comes with the Epic launcher, is it like production ready for the mobile games, or do we see? I mean, should we think that we have to customize the engine whenever we are starting for a mobile development? And yeah, it's specifically for the 3D. For the 2D, it has a different pipeline, but my question is specifically for the 3D games.
That's a very good question, and this is a feedback we get often. In fact, we have been getting quite often saying like, hey, is Unreal Engine suitable for mobile? All of the things that
Yeah,
we just talked
I
about.
always get some questions that is
Yeah.
Unreal good for mobiles, because I play Wuthering Waves. At first, when the Wuthering Waves was released, it was not optimized, and also like there are so many Unreal Engine game. I mean, the optimization of games are like developers are saying that the is the engine's issue, not their issue, and it's also like a little bit controversial, of course.
Yeah, no, see, we have heard that feedback. And in fact, I think the talk, I hope, convinced you that we are, in fact, very, very serious about mobile development. In terms of like a lot of these things that you're talking about, like build sizes, there are ways in which you can optimize the build size to reduce it significantly, like reduction of plugins, for example, or tools that's available like the size map viewer, which allows you to view what is contributing to your build size, or even things like the source code is available, like you can literally shave off parts. Let's say you're not using any AI in your tool, in your game, remove that part. If you're not using any physics inside your game, you can remove that part if you're going through the source code and whatnot. So that ability is available, and at the same time, with UE5 especially, we have been putting a lot of engineering effort to address these issues, and I think we have solved a lot of these issues, and case in point is all of these games that you're seeing. It's no longer like there is a niche title available. Literally a lot of games that you're seeing coming out, especially the top 12% of the games on the mobile store, on the app store, are typically made with Unreal Engine, and it is being successful. But we keep hearing feedback, and we keep implementing things within the engine to make it better and better.
Yeah, thank you so much.
Sure. Yeah. Yes.
Hi. As a Unity developer, most type of games you work is primarily 2D, and we don't use 3D models and such. We are just basically using images and assets.
Yeah.
What kind of support does Unreal gives on those fronts?
So let me tell this you like upfront, right? Like if you're making a hyper casual kind of game, I think Unreal Engine is an overkill, right? Because Unreal Engine, if you're making a nice 3D world, like a AA, AAA title, no brainer, you have to use Unreal Engine. But if you're making a kind of like a hyper casual game, it doesn't make, you're not, it's like essentially you're putting a Ferrari engine on an Ambassador car and then trying to ride the Ambassador car, which doesn't make, you can still do it, but it doesn't, yeah, it's just like an overkill. Yeah. But that said, there are some really nice games like, Born Monkeys, which is a studio in India. They made a really good game called Dodo Ducky. It's available in the Unreal Engine booth. It's a side-scroller game, but it also changes perspective. Casual couch co-op kind of a game. amazing looking, and they really built on top of the power that Unreal Engine gives them. Looks casual, but actually there's a lot of mechanics behind the scenes. So yeah, that's my answer. Like, yeah, that's pretty much it. Yeah. Mhm.
Thank you, everyone. I think that'll be the last question for today. This is wrapping up the Tech Track talk for today.
Can I ask you a favor? Can I just take a selfie with all of you, saying like "yay" or something? Like IGDC. I think if you say IGDC, everyone will be smiling at that point of time. Can I have that? Yeah. All right. Cool. Let's do that. Oh, IGDC. Yay! Thank you. Yeah. All right. Well, I hope you all have a great IGDC. There's also the jury awards that's coming up next. Amazingly phenomenal games that's coming out. I was jury myself, so I've seen a lot of those games. So it's going to be there. If you have any questions, I'll meet you there. See ya.